Namaste. Welcome to Free DCET Coaching 2020 organized by Maharaja Institute of Technology, Thandavapura. Myself, Channabaswana SG, working as Assistant Professor in the Department of Mechanical Engineering, MIT Thandavapura. So today I'll be discussing topics related to theories of machines. Topics that I'll be discussing here will be basics of kinematics of machines and friction. Kinematics of machines. Kinematics of machines is a part of theory of machines. So how do you define the kinematics? Kinematics is a subject that deals with the study of motion of objects without the consideration of forces which are causing the motion. How do you define a machine? Machine can be defined as any device that is used to transfer and transform both the motion and force from an input to output. Okay. So coming to some of the basic definitions of kinematics of machines. First one is the kinematic link or element. Kinematic link or an element is basically a resistant body. A resistant body here means that it doesn't deform easily when it is applied with some forces or loads. So in fact, link is a part of machine which has relative motion with respect to another machine part. Okay, talking about some of the examples of the kinematic link. If you observe a single slider crank mechanism on the right side, you have four different links here. Those are frame, crank, connecting rod and the slider. So these all four form different links which have relative motion with respect to each other. So what are the different types of links or elements that you can classify? Kinematic links can be classified as rigid links, flexible links and fluid links. Coming to the rigid links, any link which can transmit the motion without any deformation is called as a rigid link. For example, crankshaft or connecting rod can be understood as an example for a rigid link. Coming to flexible link is a type of link which partly deforms while transmitting the motion. For example, belt or spring. Most of the cases, the flexible link undergoes the elastic deformation. Third one is the fluid link. A fluid link is a type of link in which the motion is transmitted through the fluid by the application of pressure. Okay, hydraulic pressures, hydraulic press or hydraulic brakes or jacks are the examples for the fluid link. Based on the number of joints any link carries, I can classify the links as singular link, binary link, ternary link and quaternary link. Here if you observe in a singular link, it has one particular joint at the end wherein I can join another link at this particular joint. In the binary joint, I have two joints at which I can join two more links like this, right? So in the ternary link, in the similar fashion, this whole triangle is a single link wherein I have three ends at which I have three joints wherein I can join three more links. So these are the different possibilities of a ternary link. And in the similar fashion, I have quaternary link wherein I have four different joints at which four different links can be joined again. So links are also classified based on the number of joints it carries. What is a structure? A structure can be defined as an assemblage of number of links or resistant bodies which are having no relative motion between them. So basically a structure is designed to only take up loads. Okay. So for example, railway bridges, a building or a truss are the examples for the structure. So how exactly are they different from a machine? As I mentioned earlier itself, a machine will be having relative motion between its parts, whereas in the structure there will be no relative motion which will be existing between the members. Whereas in the machine, links are meant to transmit both motion and power, but whereas in the structure the members are designed only to transmit loads or forces. The examples of machines are lathe, shaper machine, steam engine. Whereas in the structure, if you talk about structures, railway bridges, buildings and machine frames, many examples can be given. How do you understand degrees of freedom? Degrees of freedom can be understood as the number of independent relative motions any kinematic pair can have. It might be translational motion or rotational motion. The number of independent relative motions can be understood as the degrees of freedoms. Okay. In fact, kinematic pair can be defined as a combination of two or more links or elements of a machine which are in continuous contact with each other, and they're in such a way that they have relative motion with respect to each other. Very important. Both conditions have to be satisfied for becoming a kinematic pair. They should be in direct contact with each other and they should have relative motion with respect to each other. If I talk about the same example of single slider crank mechanism that I have discussed in the previous slides, the link 1 and link 2 are a kinematic pair because they are in direct contact and also they have relative motion with respect to each other. Even though link 1 and link 3 are having relative motion with respect to each other, they are not in direct contact. So I cannot call link 1 and link 3 as the kinematic pair. So likewise, link 2 and link 3 are in contact and they are called as kinematic pairs. And likewise, 3 and 4 have relative motion and they are continuous in contact. They form a kinematic pair, 3 and 4. And likewise, 4 and 1 form a kinematic pair. Now let us discuss some of the constrained motions that the links of a kinematic pair can have. The first one is the completely constrained motion. Here in the completely constrained motion, the links will be having a specific or definite direction in which the motion is happening. So if the motion between a pair of links is limited to just a definite direction, irrespective of the direction of force applied, then I call it as completely constrained motion. The example is the piston and the cylinder. Here the piston and cylinder are the kinematic pair. No matter what direction I apply the force, the link 1 should always slide up and down against the link 2. Okay, so this is the example for the completely constrained motion. The second type is the incompletely constrained motion. Here, whenever the motion between a pair of links or just the motion between the links is not just confined to one particular definite direction, but it is more than one direction. So whenever there is more than one or more specific directions in which the motion can happen between the links, then it is called as incompletely constrained motion. The best example here is a shaft, a circular shaft that is inserted into a circular hole. See, the circular shaft can slide and also it can rotate. So there are two different ways with which it can move or rotate, right? So a circular shaft in a circular hole may either rotate or slide in a hole. So that is the example for incompletely constrained motion. The third type of constrained motion is called as successfully constrained motion, or it is also called as partially constrained motion. Here the motion in a definite direction is not brought by just itself, but by some other means I can control the motion. Say for example, if I have the footstep bearing like this, right? Here I have a shaft which can both rotate and also it can move upward and downward, right? It can slide upward and downward. So say for example, if I place a load on this shaft so that the shaft doesn't move upward and downward, so it becomes stationary with respect to linear motion. So the only motion left for it to have is the rotational motion, is it not? So the only way it can rotate or the only way it can move is it can rotate, right? So this possibility of converting to completely constrained motion from an incompletely constrained motion is the third type of constrained motion that is called as successfully constrained motion or partially constrained motion. It is very difficult to understand, but it is a possibility of constrained motion wherein I can convert the incompletely constrained motion to completely constrained motion. Okay, so that kind of constrained motion is called as successfully constrained motion. Okay. Now let us try to discuss the classification of kinematic pair based on the type of relative motions the kinematic links have in a kinematic pair. Okay, based on that we have 7 different types of kinematic pairs, namely turning pair, prismatic pair, screw or helical pair, cylindrical pair, globular pair, flat or planar pair, and finally we have rolling pair. So we'll try to discuss each one of them. First one is the turning pair. Okay, here in the turning pair you have one link which is having purely rotational motion with respect to another link. So if you observe here, there is a shaft A which is inside a bearing B. Then shaft A is having purely rotational motion here, right? So because if you can observe here, there are two keys present at the ends so that it doesn't slide. So there is only purely rotational motion. So in that case, when I have two links which have relative motion purely rotational or purely turning motion, then I call it as turning pair. So as I told you, the degree of freedom is 1 here because only one way it can move, that is the rotational. Coming to the second one, it is the prismatic or the slider pair, wherein one link is trying to have purely translatory motion. or the sliding motion. So if you observe here, link A is having purely sliding motion in the slot provided in the link B, right? So it is a prismatic or slider pair. So the degree of freedom is again 1 because it has got only pure translatory motion. In the third type, that is the screw or helical pair, we have a link A which is a screw. So when I give rotation to the screw, automatically based on the direction of rotation of the screw, it automatically moves upward or downward, is it not? So there is a combination of rotational motion and as well as the sliding or the translatory motion. So even though there are two types of different kinds of relative motions, I cannot call the degrees of freedom as 2. Why? Because there is no pure rotational motion or there is no pure sliding motion as such. There is a combination of the rotation and sliding, but there is no pure rotation or there is no pure sliding motion. So that is why degree of freedom in the screw or helical pair is remaining as 1. So coming to the fourth type of pair is the cylindrical pair, wherein I have a cylindrical shaft that is being inserted into the pin of, or maybe a hole of the link B. Just in comparison with the turning pair, just in the turning pair I have two keys using which I will prevent the sliding or the translatory motion, but in this case of cylindrical pair I don't have those kind of keys. So there is provision for the shaft to also slide along the horizontal direction. Okay, so as well as it has pure rotational motion, it has also got pure sliding motion. So the degrees of freedom becomes 2 because it has got independently 2 pure rotational motion and sliding motion, right? So that is the reason the degrees of freedom for a cylindrical pair is 2. The fifth one is the globular or the spherical pair. It is very much similar to the ball and socket joint, wherein this link can independently rotate along 3 different axes, that is x, y, z. So that's why degree of freedom is 3 for a spherical or globular pair. Coming to the next type, that is the flat or planar pair. The pair permits a planar relative motion between the contacting elements. See here, this relative motion can be described in terms of 2 translatory motion, that is in x axis or the x direction and along the y direction, pure translatory motion. Along with these 2 translatory motions, I have the provision to rotate this particular element along the z axis, right? So the total number of independent motions it can has is the 3, right? So totally the degrees of freedom becomes 3. And coming to the last type of pair, that is the rolling pair. Here, when the links of the pair have a rolling motion relative to each other, they form a rolling pair. In a roller bearing, for example, the roller are rolling on the surfaces of inner rays of the link B. You can observe the inner rays of the link B here. So these rollers keep on rolling in contact, that they keep in contact with the inner rays of the bearing or the link B. Okay, so the roller bearing is this. Now let us try to classify the kinematic pairs based on the type of nature of contact between the elements. Okay, so based on the nature of contact, there are higher pairs and lower pairs. What is higher pair? If the kinematic links are having point of contact or line of contact during the motion, then those kind of pairs are called as higher pairs. The examples are roller bearings or ball bearings, belt drives, gear drives, and even cam and followers. Okay, and coming to the lower pairs, on the other hand, lower pairs are the kind of pairs which have the links which are in continuous surface contact. Okay, when 2 or more links are having surface contact between them during the motion, those kind of pairs are called as lower pairs. For example, turning pairs, sliding pairs, twisting pairs, and even screw pair. So you can observe the turning pair here, wherein the shaft will be having surface area of contact between the with the bearing. So the area of contact between the bearing and shaft you can observe here in the turning pair. So it is a lower. Now based on the nature of mechanical constraints between the elements, the kinematic pair can be classified as closed pair and unclosed pair. Okay, in the closed pair, when 2 elements of a pair are held together mechanically in such a manner that only the required type of relative motion occurs, then that kind of pairs are called as closed pairs. Okay, so you can refer the figure here. It is an example for closed pair. It is an actual diagram of an enclosed cam and follower. So here the cam is mechanically held within the follower. You can observe here, right? So the mechanical action is the reason behind the cam being held with the follower. Whereas in the other case, in the case of unclosed pair, when two elements of a pair are held not by mechanical forces or mechanically, but they are held in contact by the action of external forces. Okay, when they are held by action of external forces, we call it as unclosed pairs. Okay, so you can observe knife edge cam and follower here, which is loaded by spring. So due to the external force, by the action of force of spring, they are held together. The follower and cams are held together. So that kind of pair is called as the unclosed pair. Okay. Now let us try to discuss some of the basic definitions like kinematic chain. So how do you define a kinematic chain? A kinematic chain is any group of links connected together for the purpose of transmitting force or motion. Okay. What do you mean by a mechanism? See, whenever I try to fix one particular link in a kinematic chain so that the arrangement can be used to transmit or transform the motion in a useful manner, and this arrangement is known as mechanism. So mechanism, in fact, by fixing one of the links of the kinematic chain so as to obtain the specified or particularly wanted kind of motion, is called as a mechanism. Okay. So how do you define the inversion? Right. So inversion is a method of obtaining different mechanisms by fixing different number of links in a kinematic chain, and that process is called as the inversion of a given mechanism. Right. So if you have 4 different links in a kinematic chain, if I fix 4 different links at 4 different point of times, I get 4 different types of motions. Right. So that is nothing but 4 different inversions of a given mechanism. Okay. From the practical point of view, there are 3 different types of kinematic chains. Okay. Those are 4-bar chain, single slider crank chain, and double slider crank chain. Okay, these are all the 3 different types of kinematic chain. From the syllabus point of view, you have got only 4-bar chain mechanism to study. So coming to 4-bar chain mechanism, any 4-bar chain mechanism consists of simply 4 rigid links which are interconnected like this in the form of a quadrilateral. They complete a quadrilateral by joining at various pin joints. Okay, they are connected by pin joints at A, B, C and D. Okay. In a 4-bar chain mechanism, the link that makes the complete revolution is the crank. So any link which makes the complete revolution is called as the crank link. So here the link number 2 or link AB is the one which has the complete rotation. So that is why it's called as crank. Okay. Any link which is fixed, which doesn't move, is called as the frame or fixed link. So this link number 1 is the fixed link. So the link which is opposite to the fixed link or the frame, I'll call it as the coupler or the connecting rod. Okay. So the link which oscillates about an axis or a point is called as the rocker or the lever. Okay. So 1, 2, 3, 4. These are all the 4 different rigid links by using which I form a quadrilateral type of mechanism that is called as 4-bar chain mechanism. Now let us look into some of the inversions of 4-bar mechanism. So by basically fixing different links at different stages, I get different kinds of motions or different kinds of mechanisms. So out of which first one is the crank and lever mechanism, or commonly called as beam engine. Okay. So in this mechanism, the basic purpose is to convert the rotary motion at one end to the reciprocating motion at the other end. Okay. So whenever the crank AB rotates about the fixed point A, as you can observe here, the lever CDE also oscillates, right? So because they are connected by a connecting rod or a coupler. So at the other end of the rocker or the lever, the E is also reciprocating. So that is connected to a piston or the cylinder, piston of the cylinder. Then the rotary motion is completely converted into reciprocating motion. So this kind of beam engine or crank lever mechanism is used in the oil wells to extract oil from the underground. Okay, so that is the application of this crank and lever mechanism. So the second inversion of a 4-bar mechanism is called as double crank mechanism, or commonly called as coupling rod of locomotive. Here in this mechanism, the length of AD will be equal to the length of link BC, and in the similar fashion the length of link AB will be equal to the length of link CD. So they form a perfect parallelogram. So these are actually the wheels. Okay, so here what happens is, whenever the link AB rotates about the point A, the link CD also rotates about the point D. Okay, so since both the links, opposite links 2 and 4 rotate, we get double crank here. So that is why it is called as double crank mechanism. Okay, so these kind of mechanisms were used in the older type of locomotives. Okay, older trains alli idana use ಮಾಡ್ತಾ ಇದ್ರು. So now they are not in use, but this is one of the important type of inversions of the 4-bar mechanism, which is called as double crank mechanism or coupling rod of a locomotive. Okay, the last type of inversion of a 4-bar mechanism is called as double lever mechanism, or commonly called as Watt's straight line mechanism, which is basically used to draw approximate straight lines. So here in the double lever mechanism, you can observe the link AB and DE act as levers or rockers. At the ends, we can observe the end A and end E are fixed. Okay, so during the mean position of the mechanism, the links AB and DE are perfectly parallel, and the connecting rod BD will be perpendicular to the both the parallel levers. Okay, only on small displacement of the mechanism, right? So somewhere I give motion. Say for example, I try to give motion at this point of AB. So whenever there is small displacement of the mechanism, the tracing point C, which is the middle point on the link BD, traces a shape which is very similar to 8. Okay, so that is how the entire mechanism works. Okay, so the center point C of the link BD traces an approximate shape of 8, and out of that approximate shape of 8, the major portion straight line will be approximately straight line. So that is why we call it as Watt's straight line mechanism. So this kind of mechanism is used to draw an approximate straight line. Okay, so this is the double lever mechanism. Okay, so far we have finished the basics of kinematics of machines. So coming to the next chapter or the topic, that is friction. So how do you define the word friction? Friction can be defined as the resistive tangential force that is acting at the contact of two surfaces which are trying to move relatively to each other. Okay, so whenever there are two surfaces which are having relative motion with each other, or whenever the surfaces are trying to move relative to each other, then the resistive force which is acting tangentially at the point of contact, that force is called as friction. So basically it's a force. Okay, in many instances the friction is desirable, and many other instances the friction becomes undesirable, starting from a bullock cart, right? So even bulls require the friction to walk on the floor or walk on the ground. Even we require, right? So it is most essential factor to be considered. And at the same time, the friction, lot of higher friction leads to wear and tear and power losses at the the point of contact between the shaft and the wheel here, right? So bearing friction losses, it has to put more efforts. So like that, at the same system, the friction can work in the desirable manner, or sometimes it can work in the undesirable manner. So many of the other instances include the machining operation, right? So you need friction for the proper machining of workpieces. At the same time, higher friction leads to tool wear, right? Tool gets blunt, right? So even at the brakes and clutches, you need proper frictional forces to stop the vehicle or to stop the rotating machine elements. Even to transmit the power from one point of contact to other point of contact, we require friction, is it not? And even if you talk about the undesirable properties of friction, a lot of tools get worn out due to friction, right? So many of the instances friction works in favor of us, and in other instances friction works against us. So we generally call friction as the necessary evil. So that is the background of the friction. So that is why we have to study the friction, so that we can optimize that. So we need not necessarily reduce the friction always, we have to optimize the friction. Okay. So coming to types of friction, there are types of friction depending on the nature of surfaces. So depending on the nature of surfaces, we have two friction, that is called as static friction and dynamic friction. Okay. So in the static friction, if the two static surfaces or the two surfaces which are in contact are at rest, the forces experienced by one of the surfaces is called as static friction. In the dynamic friction, if the two surfaces which are in contact, whenever one surface or two surfaces are trying to move over other, then the forces experienced by the moving surfaces to resist the motion is called as dynamic friction. Okay. So that is the classification of friction depending upon the nature of two surfaces. So coming to the other type of frictions based on the condition of two surfaces, I have dry friction, greasy friction and film friction. Here in the dry friction, whenever there is no use of lubricant or oil or grease between the relatively moving surfaces, then I call it as dry friction. Okay. So in the greasy friction, when I try to separate the moving surfaces by adding some very thin layer of lubricant, okay, very thin layer of lubricant, if I add between the moving surfaces, I call it as a skin friction or greasy friction antanu kuda kariteve. And the last type of friction based on the condition of two surfaces, I call it as film friction or viscous friction. Whenever I try to separate the two moving surfaces by applying some thick layer of lubricant between them, so that I will completely avoid their contacts during the motion, so that kind of friction is called as film friction or viscous friction. Okay. So these are all the types of friction. Now we shall try to discuss the concept of coefficient of friction by quoting a very simple example like this. So let us try to assume that there is a flat stationary surface like this, on which there is a rectangular object like this, which is trying to move with some constant velocity, okay, towards the right. So obviously due to the point of contact between them, there will be some tangential frictional forces which will be acting against the direction of motion. So obviously the rectangular box or the object will be having some weight which will be acting towards the center of the earth from the center of gravity of the object, is it not? So here according to Leonardo da Vinci, frictional force is directly proportional to the normal force. Okay, he was the first person who concluded that the frictional force is always directly proportional to the normal load. So F is directly proportional to capital N. So here that proportionality constant that I get from the relation between the frictional force and the normal force, I call it as coefficient of friction. In fact, if you want to define the coefficient of friction independently, coefficient of friction is nothing but the ratio of frictional force to the normal force. Okay, so mu is nothing but coefficient of friction. So in fact, coefficient of friction is dependent on various other factors. It is a system property. Based on different materials, the coefficient of friction varies. The next concept is the limiting angle of friction. Okay. So to understand the limiting angle of friction, we have to understand the diagram here. So with the same example of the object which is trying to slide on a flat surface will be subjected to friction, right? So frictional force is acting in the opposite direction to the motion. So obviously when W is the weight or the normal load which is acting from the center of gravity towards the Earth's center, obviously there will be a reaction, equal and opposite reaction to the weight due to Newton's third law, right? So using these two forces, frictional force and reaction force, I can have a resultant force called as S. Okay. So the angle between the resultant force S and the reaction force R, that angle is called as limiting angle of friction. So by definition, it is defined as the angle made by the resultant of the normal reaction and the limiting force of friction with the normal reaction. Okay, that is denoted by 5. Okay. So From the figure, you can observe that tan phi is nothing but the ratio of the opposite side by the adjacent side. So that is nothing but f by r. So here f is nothing but mu r with the concept that we studied in the previous slide. So f is equal to mu r, right? So coefficient of friction times the normal reaction or the normal load, f is equal to mu r. So r gets cancelled and ultimately coefficient of friction is the one which remains. So tan phi is equal to mu, that you have to remember. Okay, so this is known as the limiting angle of friction. Coming to the last topic of the session, angle of repose can be defined as the maximum inclination of a plane at which a body remains in equilibrium over an inclined plane due to the friction only. Okay, if you observe this figure, an object of weight W is being inclined on a surface which is having an angle of alpha with respect to the horizontal plane. Okay, so here whenever the frictional force F is equal to W sin alpha, the object tries to stay in equilibrium. So that is what I have written here, F is equal to W sin alpha, equation 1. So you know the reaction is there whenever there is weight component, the reaction will be against it. So R is equal to W cos alpha. So I call it as equation 2. So if I divide equation 1 and 2, I will get F by R is equal to sin by cos alpha will be tan alpha. Right. So F is nothing but mu R divided by R. So R component gets cancelled. So only component remaining is the mu, that is the coefficient of friction, will be equal to tan alpha. Okay. If I just recall the equation that I got in the previous slide, tan phi is equal to mu. That is what I have got in the explanation of angle of friction. Right. So when both angle of tan of angle of friction and tan of angle of repose are equal to mu, obviously the angle of friction and angle of repose will be equal. So that is the conclusion that I can draw from the concepts of the angle of repose and angle of friction. Okay. So I really hope that the session will be useful for your DCET preparation. I wish you all the best for your examination. Okay. Thank you. Thanks for watching.